Really quick review here. So we had started unit 1.2 on Thursday, which was looking at stuff like the Pythagorean theorem, which is basically you're looking at triangles, right? Looking at right triangles. If you have two sides and you need to find a third side, you use Pythagoras. We also looked at our first little thing of trigonometry, the tangent ratio, which is tangent of the angle is equal to the opposite side divided by the adjacent side. We use this the second that you have an angle and you need to find the side, or when you have two sides and you want to find an angle. Basically, the second you have angles involved, you know you need to use the tangent ratio. You know you need to use trig. So it depends. Am I looking for sides or am I looking for angles? It's important to not only know how to like solve each of these, but identify which is the one that I use. I promise you by the end of it, you guys should all be able to do these things. The difficult part is identifying that, I need to do this. It's analyzing the problem. So we have two more things here, which is going to be grade and pitch. So we're going to finish up unit 1.2 today. So I really quickly, though, want to go back to what slope is. Now, if you remember, slope was one of those things we looked at the very, very start of this. Slope was how steep something is, right? So how can we use all this together? Well, we're eventually going to be looking at stuff like roads. How can you determine how steep a road is? Has anyone here ever driven from like Jasper to like Vancouver at all?
Yeah.
Crazy steep, right? Like you have to floor on your brakes the whole time you do that. Like you think you're gonna die, it's that steep. Or like, you've been on a really steep road, maybe in winter or something, like, oh my God, like you're just white knuckling your steering wheel.
There's those little runoffs, I think they're called.
Yeah, like sand pits, yeah.
We saw one, he must have lost control of his brakes, but he had to go up that much.
Yep.
Yeah, here comes this. Yeah, Jasper. And then the main town from Jasper to that main town? Yeah. Yeah. And sometimes we need to know, especially if you are a commercial extended driver, especially if you're using roads on other conditions, is how steep can you go? And it's really hard to say, like, is it this steep? Is it this steep? Like, you need to be able to express that mathematically. So that they know. And we can use percentages for that. So that's kind of what our grade is going to be. And pitch is kind of some stuff we're looking at. So we're going to look at grade here. But basically, so because slope is equal to the tangent, this is on page 12. So this is just a note for our tangent ratio up here. And this is what's used for grade. And like I said, I am live streaming. If your eyes aren't too good, I am live streaming. But because slope is equal to the tangent of the angle of elevation, that's like looking up. You can convert the angle of elevation. Basically, you can convert an angle to a percent grade by using tangent of theta times 100. And I'll explain what this means here shortly, but this is a fancy way of saying you can turn an angle into a grade. And we use those grades to help determine how steep something is, particularly a road or a ramp or something. Again, like imagine that you're designing a ramp for people who are in wheelchairs, right? There's certain rules you have to follow on steepness. You can't just have a crazy steep ramp. They're not going to be able to get up it. And so these are how they measure those things. So this percent grade thing, you don't have to underline this. I'm just underlining it to kind of show it. So this is what we're looking at here, percent grade. So when we say the grade of something, we're talking about how slanted, or sorry, how steep a road or surface is. So grade is just showing how steep it is. It's given a mathematical number to it. It's expressed as a percentage.
Cool. So we already know how I can find how steep something is, right? If I have a ramp, let's imagine, well, I guess we kind of do have a ramp. We have a walkway up here, but if you have a ramp to a building, how do you figure out how steep it is? Well, you find the slope, right? How far does it go? And then how high up does it go? Rise over run, right? We know how to do that. We know how to find a slope. It's rise over run. So how do you find how steep something is? Specifically as percentage? Well, what we do is to convert a slope to a percent grade, multiply the slope by 100. And that's it. So if I, sorry, I'll uncover that in a second, but if I have a slope of, I don't know, 3/4 or something, that's a bad example. Let's do 3/100. All I have to do is just times this by 100, and it's going to give me that percentage. So I'll say, oh, this ramp you have has a 3% slope. 3/100 is just going to be, yeah, for every 100 feet far it goes, it rises up 3. It's not very steep. You see those if you go on hikes, right? It's hard to say, like, how steep is the hike? They use numbers to kind of quantify that. 3% doesn't seem like a lot, but if you try and do like a 5-kilometer walk up a 3% grade, your legs are going to be burning after. It's not a lot, but it still does it still does, you still feel it. Another way of thinking about this is that your percent grade is equal to your rise over run. Oops, not ruse. It's equal to your rise over run times 100. So let's go use this. Let's go do this in an example here. I'll wait till you guys all have all written down. Okay, so is that making sense though? So if I say something has a 5%, you don't need to write this down. If I say it has a 5% grade, that's the same thing as if it has a rise of 5 and a run of 100. So it's not that steep. That'd be something like, let's see, this is perfect. That'd be something like this. That makes sense. Not that steep. There's like 20% to be a little steep, right? So there's laws on how steep you can make roads and specifically like ramps for people with wheelchairs. There's law, like you can't just have like a slip and slide. It will not work that way. All right, so let's go into this. So we're going to go down one page. We're going to go to our next page here, and we're going to go to question 3. Here we go. You're going to notice most of the stuff we're going to be doing is actually going to be word problems. So most of the stuff we do is word problems. Now, we've already shown on Thursday that we all can do the math. We all can do the math part of it. Now it's just figuring out what is the question asking us. So in this case, we have Martin's driving a truck on the Trans-Canada Highway. There's a sign indicating it's a 7% grade of the road. So first off, what I like doing is I like drawing a graph for everything, for literally everything. So if he's driving on something that has a 7% grade, we instantly know it's talking about rise over run. So I'm going to quickly draw that. I'm just going to draw a nice, a right triangle here, because it's all we're working with is right triangles. And so if it's a 7% grade, that means rise over run, right? So what would be in my rise part?
7.
7. And what would be my run part?
And then 100 would be the
Perfect.
Wow.
Yeah. So the run would be 100. And is that making sense where I'm getting those numbers from? All I'm doing, I'll come down to this in a second. All I'm doing is the opposite of what we did up here. To convert a slope to a percent grade, I multiply it by 100. If I'm doing it the other way, 7%, well, percent, we talk about percent. You do not need to write this down, but I'm going to be referencing this a lot. Percent. We don't really use it anymore, but cent is a penny, right? Cent means 1 out of 100. So if I say 7%, it's just 7 out of 100. That's where that term comes from. So that's where I got that magical number 100 from. Is percent literally means over 100. All right. So what's the slope of this?
7 over 100.
Yeah, we know how to do this. This is just rise over run, right? M equals rise over run, which is literally just going to be 7 over 100. So that means it goes up 7 meters for every 100 meters you go, or it goes up 70 meters for every kilometer, and so on and so forth. I can't simplify this, so this is the final answer here. I cannot make this any smaller. Cool. So now I want to find the angle of elevation of the road. So right away, it's asking for angle. I'll talk about this elevation part in a second. What do you know I need to use? Tangent, yeah. The second there's an angle involved, cool, I'm using trig. So I still have my same graph up here, so let's go through that. I'm gonna put my blank formula in. Tangent of theta is equal to opposite. I'm gonna put O over adjacent. If this is too messy, I can go back to the text tool. Please let me know. I can only make it so big, but I can make it neater if this is unreadable. So tangent is equal to opposite over adjacent. That's my first step. My next step was I needed to label my triangle. Which one of these is my hypotenuse? 7, 10, 100 or blank?
Blank.
Blank, right? Because it's opposite of that right angle. Now, which one of these is my opposite?
Be 7.
So it would be 7. So this is where I bring up that angle of elevation part specifically. It is referring to this. Angle of elevation. Elevation means up. So imagine you're this person here. You're looking up a hill. Your view is elevated. Elevation. It's that one right there. So angle of elevation. So I'm just putting a little theta here. Not very good, but I'm putting that there, which means my last side has to be adjacent, right? Hypotenuse is opposite your right angle. Opposite is opposite of your angle that you're given. And then angle, and then adjacent is just the last side left. So cool. Now all I have to do is fill stuff in, right? I don't know what my angle is. So I'm going to leave that blank, how it is. But I know what my opposite is. My opposite was 7. My adjacent was 100. Now remember, I don't want what the tangent of the angle is. I want to know what the angle is. Which means I need to get rid of this thing here. Which then, right now it's tangent times the angle. I need to do the opposite of dividing by tangent. We already know that this breaks your calculator. So what do I need to do that? I need to use that second function. So what I'm going to do is I'm going to use second function. I'm going to use tan. There's that little -1 there. If you have that -1, that means you're doing that inverse of it. And then I just put my fraction in there with this little AB button, right? So second function, tan, AB button, 7 over 100. 4.0041. I'm just going to put 4. My angle is 4. 4 degrees specifically. And does that make sense? Like, that's a really small angle, right? But if you're driving down a road, you don't go over a lot of really steep things. It's usually very small changes in elevation, right? Only when it's literally involving mountains do you go down those crazy steep roads or up them. Sorry? It's yeah, oh yeah, it's terrifying. I had to go the West Coast, like San Francisco to Washington, like somewhere along there, I forget which one. I was going up a mountain and like the roads are really narrow and like yeah, it's terrifying, and I'm a pretty confident driver. Okay, but that's it. So when we're talking about grade, it's just understanding that that's just a fancier way of saying slope, right? So let's go into our final thing for today. Sorry, does everyone have that down? Okay, let's go into our final thing today, which was pitch. Ooh, I did not leave myself a lot of room here. I'm going to make this blue just to make it stand out for you guys. So I apologize. I did not leave myself a lot of room here. So basically, a pitch is just a slope. We just show it a little bit differently. Like 7% is the same thing as 7 over 100. We just go back to our ratios here. So basically, we express pitch as a ratio or proportion. I've spelled that wrong. So we express pitch as a ratio or proportion. And so what do we use? We use this for stuff like to show how steep a roof is, for example. So basically, it's expressed as, it's expressed as number of inches or whatever measurement you're using, feet, number of inches of rise of rise and run, basically. So for example, a roof that rises 6, I'm putting a little quotation mark, that means inches. I'm just gonna put inches. A roof that rises 6 inches for every 12 inches would be 6 to 12. Here, let me make this a little easier. Nope. Okay, let's do this instead, and I'll just zoom in. Here we go. So a roof that rises 6 inches for every 12 inches, that means would be 6 to 12, right? You rise 6 for every 12 you run, is what that basically means. If I were measuring the pitch of that road, that 7% gradient road, it would be 7 to 100. It rises 7 for every 100 that it runs.
Hey, how did that all change? Is it just the one thing by it for foot or feet?
Yes. Or do I have that other way around? Yeah, one of those represents inches, the other one represents feet. Yeah. I'm second guessing myself now. Hold on. Let me just confirm this. Okay, yeah, inches is the double line there. Okay, good, we're good. So you see this little thing, I'm gonna mark it in black. You see this thing here, that means inches. If you see one of them, that means feet. Okay. So let's do an example of this. We're gonna go down to question number 4 on page 14. All right, so let's go into this. And like I said, we just have to make sure we read and understand what the question wants. It wants to know how wide is the shed in the diagram below if the pitch of the left side is 3 to 4 and the pitch of the right side is 8 to 9. So it wants to know how wide is the shed. Specifically, it wants to know this, right? It wants to know the length of this line, which is the same as the length of this line, okay? So that's what it's asking us to find. So I don't want us to get lost on all the math we're trying to do. Everything we do is to try and find the length of this line. And so how can I find that? Well, I know that this part right here is 3.2. So how could I find the full length of this line?
3.2.
Part of it's 3.2. What do I need to find? Which line do I need to find to fully figure this question out?
The whole bottom line.
The whole bottom one. Now I know that you don't draw this in. I know the length of this part. What's the length? What am I missing now? I'm missing this part. This is what I'm trying to find, right? Yeah, we can't just be like, oh, it's half that. Like we have to actually use some math here to figure this out. So right away, here's what I know. I know I need to find this line in green. I hope that's thick enough to be able to see. I need to find this line in green. Well, I know I'm using triangles. I'm using sides. So I'm probably going to have to end up using maybe Pythagoras or something. But let's find out. Maybe I do, maybe I don't. So first off, let's talk about this stuff here. So first off, the pitch of the left side is 3 to 4. And the pitch of the right side is 8 to 9. Remember, that's rise and run. So why don't we just try solving that stuff? Maybe we can do it without Pythagoras. Because we know this measurement right here, this 3.2. So I bet you we could figure this out. So first off, we're going to set this up in a way that we're probably used to. I'm just going to write, I'm going to split this up into left and right. Let's make this bigger. So I'm going to split this up and I'm just going to put a line right down the middle. So when I'm talking about the left side, this is the left side of the roof, right? This is the right side of the roof. So I know my left side has a pitch of 3 to 4. Now, do I know either the rise or the run of this, of the left side? I know the run, I know it's 3.2. So why don't I fill in that? Does that go on the left or the right side here? That's the run. Right. Goes on the right side, 3.2. I'm gonna put meters there. So I'm gonna type that in, make it a little bit neater. So is that making sense where I'm getting this 3.2 from? And why I'm putting it here? Because it is the run of it. It's rise over run. Oh, hello? And then on my left side, I don't know what the rise of it is. But this is similar to a question that we've used before. So I know that this is a proportion, right? Which means I could take 4, I could times it by some random number, and it's going to give me 3.2. So, oh, this seems familiar. Do you remember how I figured that out? I would figure out how many times does 4 fit in here. So if I take 4, I times it by 0.8, it's going to give me 3.2. Which means if I take 3 and I times it by 0.8, it should also give me that. And right away, I can see that the answer is 2.4.
Is that a
This?
Yeah.
That's a times. Sorry, I'm a little narrow on space there.
So what did you do?
So I wanted to figure out how many times, so 4 times something gave me 3.2, right? So how could I figure that out? I could figure out how many times did 4 fit into 3.2. So I could take that 3.2, divide it by 4, and it's going to give me what that number was. Yeah, which is 0.8. So that means that this is a proportion, right? Which means if 4 times 0.8 gives me the actual run of it, I can take 3 times 0.8 and I'll figure out the actual rise of it. So that's this line right here is, what did I say that was? 2.84? I'm gonna make this
meters?
in meters. Yeah, I'm just gonna erase this really quickly. So I know that this is 2.4 meters, specifically this line, right? This is the rise of it. And now all of a sudden, so just like before, for this left side, I knew the pitch of this, I knew the slope of this, and I could use that. Okay, if I have the pitch, or if I have the pitch, I have the slope of it, because that pitch and slope are the same thing, right? If I have the pitch of it and I know what one of the sides is, I can use this stuff that we learned at the start of last week to figure out what that remaining side is. Now, if we're looking at this right side, do I know the pitch or slope of this? Well, sure. It's 8 to 9. So I know the pitch of this right side, and now do I have one of these two sides established? Yes. So I can solve it the exact same way. So now I can solve it the same way. Now, how did I solve that left side? Let's look at what I did. What did I do right here? A ratio, but specifically, I put what I know. I know it's an 8 to 9 ratio. So all I did was just put what I know. We always start with what we know, and then we try and use that to find what we don't. So this is I know the pitch of this right side, and I know that this right side here, how tall is this right side? 2.4. I know the rise of it. And so I can now use that to figure out the run of it.
So would you do it like 9 times 0.8 as well?
Not quite. That was just for the left side, but the same concept applies. I can take 8, I can times it by something to get 2.4.
Oh, right.
How can I figure out what that something is?
Divided by 2.4.
It'd be 2.4 divided by 8 is what it would be. So if I'm taking 2.4, I divide it by 8, I can see that the magic number is 0.3, which basically means I took 8, I timesed it by 0.3, which got 2.4.
How come you did it that way instead of doing that way?
Ooh, because I'm taking 2 things I know.
I started to know what 3.2 is, which means I can now I know either the rise. So I need to have 2 rises or 2 runs. I can't do it this way because I don't have the second run to use. So I'm forced to use the 2 rises to figure out that number.
Oh, okay, so you didn't do it at 3 divided by 4 the last time?
No, last time I did 3.2 divided by 4. Yeah. Took the bottom number divided by the top number base. Well, it's on the same side though. Okay.
I'm just figuring out how many of it fits in there. So the same concept applies. So I can take 9, and what can I times it by to figure out my final answer?
0.3.
I can take 9 and times it by 0.3, correct? Which is going to give me 2.7. 2.7 meters is the run of my new line, so which is 2.7. Cool. Am I done? No, because remember, this is a really common thing. You guys might get to this, you're like, yeah, done. Not quite. You're 90% of the way there. You've done all the hard work. Now it's time to do the easy stuff. The question asks, how wide is the shed? You have figured out how wide the right side is. How can you figure out how wide the shed is now? I think. I don't know together, yeah. 3.2 plus 2.9. Shed is. I'll get rid of that and just type it in. And you don't need to do this. The shed is 5.9 meters. If you just put 5.9 meters, that'll be fine. I'll accept that. Right? I know what you're talking about there.
So you would do 3.2 plus 2.7.
Yeah. Yeah, that's where I got that 5.9 from. Is I just added the left side of the shed and the right side of the shed together.
Okay, and again, just to clarify, it's the side that you have, like the ground or the rise. The side that you have two island, that's the one you have.
Yeah, that's what you use. You need because it's a proportion, right? Like think about those 2 cups of water and like 1 cup of flour thing. And then how much water would you use if I have a recipe that uses 6 cups of flour? Yeah, you use 3 times it basically. So it's that same concept, just much harder numbers.
Okay.
Yeah.
What's that E mean?
Sorry?
What's that E mean?
The E?
Yeah, like there's like a little E representing 2.7.
Oh, that's an L. That's an L. That's the line basically. Yeah. They just put it like a instead of an X or something or like a question mark, they just put that.
Oh,
Good question. Okay, does everyone have that down? Okay, so all of this stuff we're doing, it's applying it in different like real world scenarios, but it all comes down to slope is really what's all coming. It's slope and ratios. That's all it is slope and ratios. So remember, you're going to be given some questions that seem really difficult, but it can all be related back to that 2 cups of flour, 1 cup of water thing. It can all be related back to that same concept. It's just harder problems and it's harder numbers, but it's solved the same way. So we will need to become masters of this. This is stuff we're going to be using all throughout the entire year. So what you guys can do here is this is your chance to master that. So I'm just going to go up for a second. The goal here by the end of today is that you can do, oh my gosh, you can do lesson 1 and lesson 2. So you should be able to do all the problems before lesson 3. So the time you have for the rest of the day, which is going to be a little bit over 2 hours, it's just time to practice this stuff. And if you're unsure about something, let me know and we'll make sure that you're able to fully solve it, okay? So you get the next 2 hours to just kind of hammer those out. All the questions, lesson 1, all the questions, lesson 2, and then by the end of it, we should be good to go.
Oh, small, so that's good. Okay. When I get a form, right?
Get home. Yeah. There's more differences than similarities. Yeah. Yeah, like it looks like you put a lot of.
I don't know if this is like a mistake.
The whole point is I'm sure I haven't read it yet, but like we're gonna find out. Like,
Oh, with this, I might just like I was assuming like, see, this is like the word copy, and how I'm gonna do like get nice and neat, so I like understand like the grammar.
oh, okay.
So yeah, I don't know if like this is like.
Up to you. Like if that's what, it's like this part is not worth marks. Like this is all about we're trying to become a better writer. So we're gonna be like looking at SAT.
Oh, okay.
Yeah.
Do you want to this up or like?
Sure. Yeah. No, the whole point of that is practicing, right? We're getting ready for those like departments. Like in the closest factor?
Yeah.
Yeah, yeah.
Well, don't worry, it's easy, you just want to, but you're like you who's. One of the materials. Yeah, you can do this one, you can tell me. She tried to. You think?
Yeah.
Because I can't think it was a good job. You don't know how. I went to know what I was thinking, so I did what I did. I don't remember most of it.
Oops, still recording. And